So I'm Elina Argyridou. I'm a postdoctoral research associate at the Cyprus University of Technology under the UNESCO and ERA chairs on digital cultural heritage. So the aim of this presentation is to illustrate the unique results developed by our research team regarding the digital holistic documentation of cultural heritage within the EU ERA chair Mnemosyn project. Having in mind the importance of the creation of a memory twin, we have constructed the Mnemosyn project in order to build a methodology for the creation of knowledge. And for that, we need the information that lies in the paradata and the metadata. We illustrate here the importance of high quality paradata and metadata in 3D digitization by demonstrating the unique results of the recently published EU study on quality in 3D digitization of tangible cultural heritage, including mapping parameters, format standards, benchmarks, methodologies, and guidelines commissioned by the European Commission to help advance the 3D digitization across Europe. So the aim of the study's mapping was to further the quality of relevant projects by enabling cultural heritage professionals to define and produce high quality digitization standards for tangible cultural heritage. So here you can find the QR code of the EU study. So the project we are currently working on is called Mnemosyn, inspired by the Greek goddess of memory who was called Mnemosyn. Mnemosyn project adopts a holistic approach to digital cultural heritage, acknowledging the diverse facets and disciplines involved in preserving and showcasing our collective past. Our project seeks to integrate various disciplines, technologies, and perspectives to create a comprehensive and immersive experience of cultural heritage in the digital era. By combining the strengths of different fields, Mnemosyn project aims to develop innovative solutions that bridge the gap between the digital and the tangible, ensuring the accessibility and richness of our cultural heritage for future generations. So, the mission of the Mnemosyn project is the accomplishment of a research program centered on the digital holistic documentation of cultural heritage. The process topics include digital cultural heritage data acquisition, data processing, data modeling, knowledge management, preservation, and use and reuse. Here you can find the QR code of the Mnemosyn project, including all the case studies. So 17 heritage documentation case studies were chosen to be studied and digitized under the Mnemosyn project. The selection criteria for all the case studies were such as their use and the materials they were made of, if they were tangible or intangible, movable or immovable, and the user's needs, as all these affect the process of digitization and documentation. In this presentation, we will focus on the holistic documentation and digitization process of a specific case study, the Orologion of Philippi. In the VG study, the 3D digitization process of tangible objects can be described as an interactive model where factors like stakeholder requirements, 3D object properties, and environmental parameters can interact and rearrange entities like activities, decisions, and contexts. As a result, the proposed data acquisition process management system of the EU study offers a key infrastructure to design and manage various processes in the domain of 3D digitizing tangible cultural heritage objects. The proposed approach is summarized in this figure, as you can see in the screen, which illustrates the relationship between the complexity and the quality in a logical dynamic graph for a 3D digitization project. More specifically, the complexity of 3D digitization of cultural heritage can be defined after the stakeholder requirements are determined, the project specifications are set, the object's location and environmental conditions are known, and the object is defined. Furthermore, a very important part for the determination of the complexity parameters is the collection of paradata and specific information regarding the digitized objects. Additionally, quality is also a fundamental component of 3D digitization and cultural heritage and impacts Different parameters, such as the degree of detail, the geometric accuracy of the 2D and 3D shape, the spectral, scale and texture, material properties, and chemical composition and structural head monitoring status. So one of the primary goals and challenges of our research methodology was the illustration of the newly developed user classification. So the main purpose of the classification is to present the multidisciplinary community of experts and users involved in the documentation and knowledge of immovable and movable objects, monuments, and sites. The main criteria by which users are displayed are informational needs, including general and educational needs, trade visitors, and others. The area of expertise, including domain expertise and technical expertise, and motivations like curiosity, work, planning visits, pleasure, and learning. So here we can see two examples of the multidisciplinary community of experts and users involved in the documentation and knowledge of the cultural heritage objects. The top figure shows the user category group of an immovable object, a monument, a church, and the bottom figure shows the user category group of a movable object, and more specifically, we can see the Antikythera mechanism. Another essential part of our research methodology was the development of an integrated taxonomy of tangible cultural heritage assets, which is based on the Getty architectural thesaurus that provide a structure which contribute in the holistic documentation process. The integrated taxonomy of tangible cultural heritage assets supports the representation of movable and immovable heritage complex nature, and they are embedded in tangible heritage, separates tangible and intangible heritage with the focus on developing the tangible heritage class, and identifies where intangible heritage can be recognized, how it intersects with the tangible, and how this information can be integrated into this system. The classification of movable objects include the following criteria: the function, which covers the technical capabilities of an object, the form, which covers the typological categories of an asset, the subject type, which refers to a specific use of an object, the material or technique, which covers the physical attributes of the asset, the location or context that records the physical and temporal provenance of the asset. And finally, we have the state and condition, which covers the life cycle of the asset, including pre and post depositional stages. Additionally, a classification scheme has been developed for immovable heritage assets in a similar manner. The monuments can be classified according to the feature, which depends on the spatial temporal variables rooted into the general environment, the significance, which is intended as the main function attached to the monument in relation to the human social economic context, the components partitioning into two categories, namely space, which can be delimited indoor or not, outdoor, and built elements, referring the parts composing a specific structure depending on the segmentation of the space they provide. Now, here we can see an example of the taxonomy graph for one of the Mnemosyne case studies, the Orologion of Philippi. So the Orologion of Philippi can be categorized using the general taxonomic system, which is based on the Getty vocabularies within the classes of movable, function, furnishing and equipment, measuring devices, timepieces, and sundials, which indicates the type of this cultural heritage asset. The intangible information of this asset is recorded in the class context, which includes general and historical information about the Orologion of Philippi. Furthermore, the data and information needed to record the tangible facet of this cultural heritage asset are represented in classes such as technique or materials, state and condition, and form. Further details about these taxonomies will be given in the next slides. So here we can see the state and condition taxonomy, which is divided into two sections: the post-depositional stage of the object, which includes information about the current location of the object, and the pre-depositional stage, which describes where the object was founded. Next, we can see the form taxonomy that includes information about the shape and the corresponding dimensions of the object. More specifically, this taxonomy includes the outer ring, the inner ring, and the middle ring of the sundial with their corresponding measurements. Finally, we can see the context taxonomy, which includes the intangible information of the object, Within the context class, the data is divided into location, period, and use contexts, which include information about the original Asian production of the object. Here we will present the holistic documentation and digitization of the Orologion of Philippi, including all the research methodologies that we described earlier by using entity relationship diagrams. Further details about this taxonomy graph will be given in the next slides. We note here that for the illustration of these diagrams, we use the Draw.io software. First, we give a short description of the object. Then we give a brief history of the sundial, the state condition where we can see where it was first founded in the Octagon Church of Philippi in Macedonia, Greece, and where it's currently displayed at the Museum of Kavalla, also in Greece. Next, we have the holistic documentation of the object, including all the research work and output developed by the Mnemosyne team. This includes the form category, which provides information related to the tangible facet of the object. Additionally, it includes the corresponding radial charts, the user category groups, and the utilities and operation of the object. For the last three categories, we will give further details in the next slides. Finally, we have the references part, which includes a list of relevant sources. So here we can see the radial charts of the Orologion of Philippi. We can see the complexity and quality chart of the digitized object as described previously, which address the necessary and required effort for the digitization process, and the quality of the produced data, metadata, and paradata. Further information and more technical details regarding these radial charts can be found in the Mnemosyne project. Here we present the multidisciplinary community of experts and users involved in the documentation and knowledge of the sundial. As we can see from the graph, there are four main user categories where the experts and users are classified based on their expert area and knowledge with their corresponding subcategories. These four main categories are experts with domain and technical expertise in this particular area, like historians, chemical and material engineers. Then we have case study experts with empirical knowledge and studies of this domain, like mechanical engineers, mathematicians, archaeologists, technicians, IT specialists, and astronomers. Then we have non-experts who are motivated by this particular area, like students, tourists, the general public, game and creative industries. And finally, we have the case studies users who are involved in the use and reuse part of the process, like the educators and watchmakers. Finally, we present the utilities and operation of the Orologion of Philippi. The sundial is used for finding the local time. It indicates the time of day by the position of the shadow of some object exposed to the sun's rays. Additionally, the equation of time is related with the sundial, which shows the difference between the true solar time and the mean solar time. Furthermore, the sundial can be used for finding the latitude of a place, the azimuth, and the altitude of a celestial object. We also provide information related to the chronological and scientific frame of the creation of the Orologion. We can also see the 3D geometry of the object, which was designed in 3D form using the computer-aided design system, the so-called CAD system. Additionally, we have the 3D reconstruction of the sundial with the assistance of the software Aegis of Metashape. Also, the corresponding video is created for the 3D model of the object. Finally, we have the true functional physical replica of the sundial, which was based on the 3D model. And we conclude with the following remarks. The significance of establishing a comprehensive holistic documentation framework for the creation of a memory twin in order to preserve cultural heritage, examination of the inherent challenges and risks associated with this complex endeavor, a systematic approach encompassing the collection, recording, archiving, retrieval, and analysis of reliable and valuable data is needed. The digitization of tangible heritage demands attention to complexity and quality parameters. And chart a promising future for the preservation and accessibility of cultural heritage in order to safeguard our shared human history. Thank you for your attention.